Alright guys, today we're going to talk about writing a web server in Java. We're not really going to write a full-featured web server, right? But we're going to talk about the concepts involved when your browser makes a request to another machine on the internet. What's happening? Let's do a little Google search for port socket request. See if we can just find a little picture. So if you have a machine and you want to make a request of another machine, say you have Safari sitting there in front of you. Well, nobody's going to be using Safari most likely unless you're on your phone, but you have Chrome or whatever and you want to download something from Google. Then what you need to know is the IP address. Well, you don't need to know it, but your machine definitely does, of the remote server and what port number needs to be contacted. A port number is just a number that has been assigned to a specific communications protocol. There's hundreds upon hundreds of different communication protocols, and they're separated by their ports. HTTP, the one that we use for the World Wide Web, is on port 80. So if I want to talk to Google, my program is going to request the IP address of a remote server address, and then it's going to establish a connection using that IP address and using the port number. And if that connection is accepted, the connection will be read for the data that I send, and what I am sending is a get command because I want to get a file. What do I mean by file? Well, if you type in, I don't know, I'm going to just pick one of these at random. Quite often you'll see a file name as part of a path, right? You'll see index.html at the end of the path or whatever. Nowadays, web servers, handle all that, and if you don't specify a file name, it decides what it's going to send you anyways. But you can see that when I specify a connection using my browser, I give it a server name and then a file path, right? And if I want to, I can specify what port I want to access. It's default 80, but you could specify another one if you wanted to. So if I wanted to get a hold of Google and use another port other than 80, I could type a number other than 80 there. Now, Google's probably not listening on another port, so I'm going to instead specify :80, and it pulls it up. So on their end, they have a program listening to that specific port for connections to come in. And when a connection comes in, that port request is accepted. The data that my client, my browser, has sent them is inspected. The file name that is requested is checked. And then it constructs a response and it sends it back, just as more text. So like if I do view page source, I'm going to see all the text that Google sent me back. And it's frankly a huge amount of text just to display this little bit, right? Huge amount of text. But most of this is JavaScript or whatever, but it is text. So we want to write something that will accept a request so that I could get a hold of my own machine. Now if I want to get a hold of my own machine, I don't have a web address. What am I talking about when I want an IP address? Let me launch the command prompt, or I can probably do it from, I need to increase the font size. Right, so if I do ping and I give Google address, google.com there, it's performing a ping. It's testing that remote server to see how long it takes for a request to get there and to get back. Right? But it pinged a specific address. So there are servers out there called name servers, domain name server, DNS servers, that translate these into these. But I don't have an IP address for my home machine. Well, actually I do, right? On my own network, I certainly do have an IP address. But there's also an alias for that called localhost. So if I wanted to see how fast my own machine responded to pings, I could do ping localhost and it would tell me that I am at address 127.0.0.1. So this is the loopback address. This is how I can get a hold of services running on my own machine, is either using that name localhost or by using that IP address 127.0.0.1. All right. So when this is all working, I'm going to be able to type in localhost and have it run. Now, it's not running, right? Because I haven't written the software yet. So let's make a new file. Let's make a lecture Y file. Excuse me, project. Just going to call it web server or HTTP server. All right, now this thing uses several different classes that are part of two different packages. So I'm going to just right off the bat import java.io.asterisk. I mean, if you type io dot, and you can get a list. There's a whole bunch of things in there. And then I'm going to get import java.net.asterisk because I know I need those. All right. I need a port number that I'm going to be monitoring. So let's make a variable for the port number, right? So we need to create a server socket object. Server socket server equals new server socket listening on that port. And then we're just going to write a loop. We're just going to loop forever. No way to quit the program until the program is terminated. So while true. Now this could throw an exception just like any other kind of I/O. So it wants me to handle some exception, add some exception handling. So I'm just going to go ahead and do surround a block with try catch. All right, so now we have try. Server socket server equals whatever. All right, what are we going to do? Well, let's print a message saying what we're doing. We're waiting for a request. So system.out.println server waiting for a request on that specific port. So waiting for a request on port, come on, end quote plus port. Okay, and now we will do that. So socket with a capital S, socket equals server dot accept. Then this is just going to hang until we get a request on that port. Let's just stop there. System.out.println parentheses quote. What kind of information do we have from that socket? If I type in socket.get, it's got all sorts of information, right? It's got the internet address of the machine that contacted me. May as well print that out, right? So let's print a message. Request accepted from socket.get inet address. Now this isn't functional yet, right? It's not going to display anything on the client, but we ought to at least get some messages when it runs. Down here, we will see that we actually did get a result. when a connection comes in. So I've run it. It says server waiting for requests on port 80. Oh yeah, well let's do it. Let's try to attach to localhost or 127.0.0.1. Yeah, it didn't do anything. Connection refused. Localhost refused to connect. But over here, we did get our request. Right? The request was accepted from port 127.0.0.1. I mean on port 80 from the internet address that. Then it just flipped around and started waiting for another connection. So if I refreshed it, right, if I came over here and did localhost, it'd just do the same thing. Come back over here. That's a different looking IP address. Looks like looks like IP6 rather than IP4. Anyways, so what we have going on is working so far. Once we get a request, what are we going to do? Let's make a little itemized list of what we need to do. Read the well, I mean, I guess this could be step 1, right? Wait for socket connection. 2, once we get the socket connection, read the HTTP request from the client. That's what we want to do. And then 3, we want to construct a response. 4, we want to send that response to the client. And then 5, we want to disconnect. All right. Read the request from the client. Let's do that. We need to open up an input stream so we can get our data out of the socket. So input stream is equals socket dot get input stream. Now let's read an input stream reader. I tried doing this with a scanner like we did on Tuesday, and it kind of hung on the end of it, indicating that the request that was coming in was not terminated with a carriage return line feed, and so get line didn't work. So I'm not going to bother figuring out how to fix that. We're just going to use an input stream reader instead. Input stream reader ISR, or I could call it reader, don't care, is equal to new input stream reader passing in that input stream. Right? Like that. And now we're ready to actually read from it. So while true, we're just going to read until we get a null back from this request. Right? So string line is equal to reader dot, wait, I forgot to create my buffered reader. I don't know why we need 2 different readers, but the code examples I have showed it. So buffered reader space reader. Well, I guess I shouldn't have called it this one reader if this one's going to be called reader. So I am just going to call that one ISR actually. So buffered reader equals new buffered reader ISR. Now let's get our line of data. String line is equal to reader dot read line, and if it returned a null, then we're at the end of the buffer. I mean, if I type dot read line and don't complete it so we can read the documentation, reads a line of text. A line is considered to be terminated by a line feed or a carriage return or reach in the file end of F. What does it return? The contents of the line, not including line terminator characters, or null if it has been the end of the stream has been reached. See, I wonder why we couldn't just do ISR dot. Well, there's dot read, right? Well, I guess the functions here aren't as nice, right? They return character arrays. Don't want to do that. Like read returns a single character. So buffered reader is a nicer way of interacting with it. We're not going to mess with the other one. So string line is equal to reader.readLine if line equals null in parentheses, then break. Otherwise, let's just print it out, right? System.out.println red colon space end quote plus line. We're not actually inspecting the line, right? We're not checking to see if it's a get or a put. We're not checking to see what file name was requested or stuff like that. We're just dumping it to the screen so that we can go, oh, well, that's interesting. That's what a HTML GET request looks like. Okay. So this is reading the HTTP request from the client. We've done all that. What's next to do? Construct the response? Well, let's run it first. So I'm going to cancel that. Cancel this. Run it. All right, so we're sitting there waiting for a response, which I can see if I bring this up. Let's get a hold of localhost. So I'm going to type in localhost and hit return. Come back over here. And we see what it did. It did a lot, right? Waiting for a request on port 80. The request was accepted. And here's the contents of the request. Here's the text that Chrome sent to the server. It's a GET. A GET is a request for a file. That doesn't say which file name. So the web server just have to decide what to do if you get a general GET without a file name specified. Well, that's what Google has to do, right? We don't specify a file when we access Google. Sometimes we do. Sometimes we put, search terms in there. Anyways, we see all sorts of information, right? Like the user agent. This identifies what browser software is contacting us. That's kind of weird. It's like a trip back into time. In the 90s, there was a browser called Netscape, and then its underlying software was called Mozilla. And then there is something called KHTML, and based on that is WebKit, and based on that is Apple WebKit. Now Chrome uses KHTML and WebKit, so does Safari. Safari uses WebKit, and nowadays even Microsoft is using WebKit for their Edge browser. They dumped their old source code for Edge, and now they're using WebKit. So the big three. I'm not sure if Mozilla is using WebKit yet. We could find out. Why don't we launch Firefox and access it from Firefox? Alrighty, I had to download Mozilla to get it going, but hopefully ready now. So I'm going to access localhost. Come over here. See the results. Well, I'm not sure if that's a different one or the same one, so I'm going to stop it and rerun it. Okay, come back over. Here we go. So it's also claiming it's Mozilla. It's also claiming it supports Gecko. It's not saying it's using WebKit, so it's not using the same code base, the underlying stuff that Safari and Chrome and Edge do. That's right. It's its own thing. I don't think everything should be the same. Firefox version 75. All right. Let's do a little bit more. We have accepted the request. We've read it. We dumped it to the screen. We're going to construct a response. Well, what's our construct or response going to be? Oh, I don't know. Let's just send them the date or something like that. So we're going to need a date variable, right? Date now equals new date, right? Like that. Need to add the import for that. Not data, date with an E. Add the import for java.util.date. That needs to be an E as well. Don't know what I was thinking. There we go. Now let's make our string. String response. So our response is going to have a header. Not like an internet header, just, you know, something big on the screen that says Java server responded ! /h1. So that's just a tag, right? That's a header tag. And then let's tack on a paragraph tag. So plus equals, maybe a line break in there too. So a paragraph tag that's got the time, right? So plus now plus quote less than / p greater than, and then maybe another character term. Those certainly aren't necessary. Let's print our response just for fun. System.out.println sending response, and then system.out.println the actual response, right? But we haven't done it, but we've constructed it. All right, so we need to send a response. So we need to attach to our socket. We used an input stream to get data from our socket, socket.getInput stream, but now we need to get the output stream. Right? So output stream os equals new output, wait, no, is equal to socket.getOutput stream. And what the socket wants is not some fancy schmancy Java string class, but a series of bytes. Fortunately, Java string class has a method that'll convert to bytes cleanly. So let's make a byte array. So byte data is equal to response dot, because that's the name of our string, get bytes, parentheses, in parentheses, and we're going to specify that we want this in UTF-8, which is essentially ASCII text. You could Google up whatever UTF-8 meant. 8-bit Unicode transformation program format. Well, then it's not ASCII text, but it supports ASCII. A variable with character encoding capable of handling all 1 million valid characters in Unicode. Anyways, it's just a way of sending text back. It's a common text format used for shuttling data around on the internet. It happens just to look like text if we printed that array out. Yeah, let's print it out. System.out.println arrays.toString parentheses data. Okay, just see what it looks like. Well, we have our output stream. Let's use it. So os.write that data. And let's tell us that we sent it, right? System.out.println how many characters sent. So data.length plus quote bytes sent. So this was part of constructor response, and this was send that response to the client. I'm going to cut this comment and paste it there. And then lastly, let's just close our socket. Right, we're done with it. Socket.close. And we can print a message that said socket closed if we so chose. System.out.println socket closed. Certainly don't need the old version running, so I'm going to close that. All right. This has a high chance of working, I think. Let's go ahead and run it. Server waiting for a request on port 80. Let's come over here and try to get a hold of localhost, or 127.0.0.1. It says waiting for 127.0.0.1. I can't say that it worked. Let's go look over here and says what he said. Now see, he's hung on a read. What did I do wrong? Now this was working when I gave the lecture a couple hours ago. Let's not do while line is equal to null. Instead, we're going to do while line not is empty, or while not reader is empty. Let's do that. While, I'll do it like this. I'll do it the exact way I had it coded earlier. String line is equal to reader dot read line parentheses, and while line dot is empty parentheses in parentheses. Now we could put equals false, but instead I'm going to say while not line is empty. Then we print that we've read it, and then we get our next line. So I just need to copy this statement from here to here and paste it down here. Okay. Retry, and it worked. We did it. Java server responded. Check it out, it worked. So we could send back any data we wanted, right? As long as it was valid HTML tags. What if we send a file request in there, right? We really want index.html, like that, right? Let's go look to see what this prints out. Oh, and by the way, here's our array full of the bytes of the data that we sent. Socket closed, waiting for a response. Get. Here it comes in. Here's what we accept, and there's the file name that we want. And it's up to the web server to interpret this and to decide what file really needs to be served back, right? Pretty much you no longer have web servers just fielding requests for files. That's like 1995 technology. Nowadays, a web server, interprets this and it maps it to certain programs and or database requests, and then the database is hit and the response is constructed and sent back, something like that. Anyways, we've written a web server. That's pretty cool. All it does is send the date back, but we've written it. So what's the real takeaway here? Just trying to get the idea that you can do an awful lot with the classes that come with Java. And this syntax is pretty much stuff that you already understand, right? I mean, that you wouldn't have known which way to put them together without being demonstrated. But you know how to create an object. You know how to make a method call. You know how to use the response from one call to pass into the constructor of a new call. You know how to write a while loop, right? You do know all this stuff, and looking at this code, you can understand what it's doing, and you could modify it to do different things based on, what the get was. All right. Well, this took less time than last time, because the other thing that I did is I rewrote the code that we wrote on Tuesday using a different library in order to access localhost. And it was kind of ugly. I don't really want to do that again. I mean, I could show the code for you. Let's see if this is it. No, that's the server. I have several copies of this open now. Well, this is the lecture from Tuesday. And it does have the ability to read, to access a server. We were getting a hold of rose.edu. Let's just change this to http://localhost, right? That's the server that we're going to get. So now I'm just going to compile and rebuild Tuesday's lecture. And so it runs, and then its output, well, it blew up. Connection refused. Well, maybe I wasn't running the other one. So why don't we close that? Let's go run the server again and then try running our client again. Here's our server. Let's run that. We're waiting on that port. Let's come over here and run our client. Ooh, it's blown up. Why is that? Maybe I'm not accessing the correct port. HTTP connection. Invalid HTTP response. Well, I guess it's quite possible. Maybe we're not sending a valid response back. So maybe I should have used the code that I came up with, which was the get. And so here's what this one looks like. Let's look to see what the server did about that, though. Let's check the output. I don't know how to find the other window. I mean, where's the output for that one going? Funny, I was having better luck when it was tucked over here. All right. Run the server again. Come over here. Run the get. Why does it say rose.edu again? Oh, because this is the one that I rewrote, I guess. Maybe not. Let's try to get a hold of localhost. I swear I typed that, didn't I? Make it as a simple HTTP request. Save it. Hammer room it. Run it. We did get our crash. And I accidentally hit the close window. Well, now I'm not getting the same luck that I was having earlier. I'm just confused as to how to check my output from both windows because I'm running two programs at the same time. Maybe if I pull this out and stick that output window here, right? It'll be waiting for me to look at in a minute. That one, I hope. I'd really like it to be in parallel with the others. Oh, come on. Okay, fine. I'll stick it back over here. Try to stick this back up here. All right. Run the other one. No, it's going to crash. So here's our server. The server ran. It accepted a GET request. There wasn't very much in it, was there? It was just a GET. Didn't have hardly any information in it. And we sent a response back, but it apparently wasn't okay. So honestly, that's my fault. I'm sure that I constructed the response incorrectly. Let me go and look at my notes. It was Chrome accepted it, but browsers try to accept incorrect data just to be as friendly as possible, right? Because you might have people, writing web servers that return bad data. And as a matter of fact, I did send back the wrong response. I need to modify my server software so that before it says server responded, it really needs to have some better stuff in it. it needs to have the official response, which is to say http colon, no colon, sorry, http/1.1 space 200, and that number 200 is an OK message. But just to reinforce that it's an OK message, we're going to follow it with the word OK, and then \r, which is a carriage return, \n, which is a line feed, \r, which is another carriage return, \n, which is another line feed. There we go, and then we need to add this one to it. All right, now it actually is going to work, I'm pretty sure. So run my server, come over here, run my client. That's not yesterday's lecture. There we go, right? And so we contacted the server. The Java server returned 66 characters, and it printed out our response, which was our header. Java server responded, followed by a paragraph of text, which was today's date. And then the text message that said Java server responded. So we have two programs talking to each other. It's kind of cool. Here was the code that we did tonight, trying to get it to work. Not the way we did it here. Go back. Is on Tuesday we used a scanner. We opened the URL as a stream, and then we used the scanner to read from the stream, and it was really just a few lines of code in order to do that. We have more print messages and debug messages than anything else. The version we did tonight, and this is what took a long time to type, and I don't really see any reason to do that again because you could look at it if you care, is we used a class called URL. So we made a new host based on our host name, and then we created a connection object by calling URL open connection to that host. So we're trying to talk to, ourselves. Our request is a GET. There's also a put command when you're trying to upload data back to the server. Then we created an input stream reader, and we create a buffer reader from that. This looks familiar, doesn't it? This is how we read the request on the other side. And then we called read line, and while it was not null, we wrote what we got to the screen. Didn't even do a close, but of course when we hit the close brace here, well, I guess we did, connection disconnect. And then when we hit the close brace here, all the objects did get cleaned up by the garbage collector anyways. So if you feel like inspecting this code carefully to see what it's doing, it's just doing the opposite of the other one. The other one was waiting for a connection. This one is establishing a connection. It's not specifying a port for the connection because it knows that based on that, it has to be port 80. So when this thing creates its URL, it already knows that it's going to be talking on port 80. There might be a way to override that. I don't know. Maybe there's maybe there are parameters inside open connection, URL.open connection. Well, there's a proxy setting if you need to use a proxy server. Anyways, okay. I hope that was entertaining and educational. I'd like to just keep doing things like this for quite a while, where we take, classic little problems like how to communicate over a socket. It'd be fun to write like a little chat program where you could have two programs, talking to each other. You could type messages in, and then when you finally wanted to, you could disconnect. And you could certainly do that with this kind of stuff, right? With establishing socket connections. It wouldn't be an HTTP connection, though. There's no reason to do that via HTTP. But it would be a socket connection. Maybe we'll do that next week. We'll see what other lectures I have lined up. Alrighty, like I said, hope this is useful. So just keep working on your projects, gang.